Okay, let's take a snapshot of these numbers. The numbers in red circled 45, 68, 30, 30. Those are averages of those each cell. So average divided by 2. I simply took 45 and 30, divided or found the average of those two, got 37.5. 68, 30, average of those two, I got 49. Averages this way, row means. For the first row, second row, I've got those values. Good so far. Now, when we did this in StackBunch, it showed 43.25, but it didn't show 86.5. So I'll explain as to why. Did we write these two things? Divide by 2, divide by 2. The checkpoints that I mentioned earlier, that these, when you add, must match up to those 86.5. The numbers that are boxed or in boxes, you don't have to find them, but this is needed. So you divide by 2 to get 43.25. Yes. Since we get 43.25 using all of them, it is called the grant mean or the total mean. Your book calls it as GM. Again, I don't recommend you to look into those formulas, just be patient. We can simplify. So, grant mean, because you get the average of all those values. And in order to get that grant mean, you need to divide it from by 2. Otherwise, you're simply looking at the sum. So, I would say that create this table because we would need this table. 1, it'll help you do it using the calculator. 2, you can verify if you did things properly using StackBunch. Okay, that's it. So here is the data that I recovered. So the data is still there. Even before we started this last time, we agreed just by looking at the table, or we sort of made a guess if there will be an effect or not. And I used this table right here, where I took the averages of those to make an inference. So do we recall the hypothetical or subjective guesses that we made last time? How many main effects do we have? Let's start with that. 2. What are they, Barley?
Type.
The type of item that was shown and the number of times something was shown. So 2 different main effects. How many interaction effects do we have?
1.
Only 1. So as far as this class is concerned, only 1 interaction effect. Okay. Because we're not going to go past a table, simple table. Okay. Is there an effect due to the number of repetitions? We did write this down last time, correct? Our subjective guess. What did we write last time? Main effect due to the number of times? Possibly, I think that's what we wrote. Okay. What about going from words to pictures? Possibly. And then lastly, we did the interaction. What did we play? Possibly. Of course, in science, I can't write an article and say, possibly. That would make me look really stupid, don't it? So we do another two-way ANOVA. Select again responses in responses column. Row factor is times column factor type. Let's select plot interactions. Let's select display means. Let's select 2 key HSD. I don't think your book is doing it, but that's okay. Those are the numbers that we have, and I'll explain what those are. So the means, yes, and the grants being 43.25. Average of those two. So don't forget, we have to divide that by 2. Divide the sum 86.5 into 2. Good so far? Okay. That is our table. Row 1, it says times. That corresponds to our row factor. Type is column factor. Then we have interaction. Lastly, we have error. Now, what is another name for error from one way to another? You can write this table within. Good, you remember. Type, interaction, error, total. What does DF stand for? Can't hear you. Degrees of freedom. What does SS stand for? Sound of squares, MS, mean squares. F star is our test statistic, and p-value is what we're going to use to determine if there is significance or not. So MS, how did we find MS in one way to know? We took SS and we divide it by the degrees of freedom, right? So that over that will be 1404.5, same. One through oops, same. But over that, 390 and 195. Yes. How did we find last time the F test statistic or F ratio? Do we recall?
Like MS or
MS between divided by MS within. So, same thing. We take MS for that case, divide by the within, which is error. Same thing. I say tomato, you say tomato. Error, within, residuals, they all mean the same thing. So 1404.5 divided by 95, what do you get? 7.2. 0.3?
no, 0.
0.2. Okay, 0.3. That's MS divided by MS for error. So 264.5 over 195. What do we get? 1.35. We'll call it 36. That's MS divided by 195 again. It's the same value. Good. And lastly, we have p-value. This we are going to rely on, sample. When I do the calculator, which I'll show you how to find this. I believe that was 0.33 something.
3089.
3089.
Same thing.
Good. Table on the right is the table of means. This table on the left is simply to say ANOVA. Again, why ANOVA? We are using variances to come to a conclusion about main and interaction effects. Last time, maybe an effect due to the number of times an item is shown. Maybe there is an effect due to the type of item that was shown. There could be an interaction between the two. This seems to be a good job. Yes, from once to twice. Maybe there is an effect. Admit it has. So we go over to times. That is our row factor once twice. P-value is 0.055. Should we reject the null? No. If you don't reject the null, are we concluding that there is an effect or there is no effect? You keep in mind, null means nothing. There is an effect if we don't reject it. There is no effect. You are sticking with the null, you are sticking with nothing, so no effect. So the row factor doesn't seem to have a significant effect. What about the type of item? Is there a significant effect? Probably, why?
Because it's greater than 0.05.
So I guess I'll write it here. No matter whether it's main interaction, null means no effect. Alternative means evidence to support that there is significant effect. Now tell me, first case, we did not reject the null, no effect, no main effect due to number of times. What about the second one? Is there a significant effect due to the type of item that is shown? The p-value is 0.3089. Why is that? 0.3089.
It's greater than 5%.
Greater than 5%. If it is greater than 5%, do we reject the null?
Yes.
Why do we not do it there? It is greater than 5%.
That's not greater.
This is 5.5%.
Oh, so we don't reject.
We don't, right? P-value has to be less than alpha for us to reject. 30% is not less than 5%, so not significant. No effect. What about the next case? It is exactly the same. Is there an interaction effect? No, not significant. Good. If someone said, well, the number of times I showed something to a person and the way they recollect something are related based on this data, what would you say? That there is evidence to support that they are related, or that there is no evidence to support that statement? There is no evidence. I can show something to you 10 times, and the way you recollect things is not the same. There is actually a real study in education which shows that rote memorization is not a good way to learn things. So you shouldn't memorize, you should start. Before I end practice, the book uses a complicated notation, but this is R minus 1. Number of rows minus 1, I wrote it last time. Number of columns minus 1. Number of rows minus 1 multiplied by number of columns minus 1. Mind you, your book has a huge expression for that. I mean, if you want to use that, go ahead. The total is the total number of observations that we have. How many do we have? 8. With ANOVA, we did 8 minus 1, same thing, n minus 1. Well, if you had that, and that, you can find it, right? Because when you sum them, they should equal. Good so far? If you don't want to do it that way, easier way, well, I think we'll leave it this way. So find that, and take that away. So don't use this table. I'm going to do the exact same thing using a calculator. All you have to do is come up with this table. If you have this table, you can make inferences right away. Good? Okay, stop there. Hopefully nothing happens to power next time.